Hello everyone, today I am going to present my experiment on breast cancer classification using a multi-layer perceptron model. In this project, I used a machine learning dataset and implementation a deep learning model using a PyTorch to classify whether a tumor is malignant or benign. First question. Uh, First, I have loaded the breast cancer dataset using a sklearn library. This dataset contains a future computing from digitalization imaging of breast mass and helps in predicting whether cancer is malignant or benign. I convert the dataset into a data frame format and display the first few rows to understand the structure of the data. And the second one is selecting a feature and the target. I separate the data set into an independent and dependent variable. The independent variable denotes as X contains the input feature, and the dependent variable Y represents the target output, which is a diagnosis result. I also check the shape of X and Y to understand the number of samples and the features. Third question is to data standardization. I standardize the input feature using the standard scale. Standardization ensures that all features have a mean of 0 and a standard deviation of 1. This step is very important because it improves the performance and coverage speed of the model. And the fourth one is to split the data set. In this step, I split the data set into a training and test data. I use 80% of the data for training and 20% for testing. This helps in evaluating how well the model performs on unseen data. The fifth question is to convert a PyTorch tensor. After splitting the data, I convert the dataset into a PyTorch tensors. This is necessary because PyTorch models work with the tensors data structure. I convert the input feature into a float tensor and the target label into a long tensor. And the sixth question is defining the MLT model. Next, I define the multi-layer perceptron model. The model consists of multi-layer input layer, hidden layer with ReLU activation output layer. The network gradually reduces the number of neutrons from 64 to 8, and finally output classifies the result. The ReLU activation function is used to introduce non-linearity into the model. And the seventh one is to train the model. In this step, I train the model using a back propagation. I use cross entropy loss or the loss function, Adams optimization for updating the weight. The model was trained for 100 epochs. During the training, the loss values were monitored to ensure that the model is learning properly. And the eighth question is to a plotting training curve. After training, I plotted the training curve. The graph shows the relationship between the number of epochs and training loss. As the epochs increase, the loss decreases, indicate that the model is improving. And the ninth question is testing the model. In this step, I test the training model using the test data. I use the model to predict the output value and compare them with the actual value. This helps in evaluating how well the model generalized to a new data. And the 10th question is to evaluate the model performance using different matrices: accuracy, overall correctness of the model, perception, correct positive prediction, recall, ability to find all positive cases, F1 score, balance between precision and recall. I also plotted the confusion matrix to visualize the performance. The confusion matrix shows how many perceptrons were corrected or incorrect. In conclusion, I successfully implemented a multi-layer perceptron model for the breast cancer classification. The model achieves a good performance based on the evaluation matrices. This experiment demonstrates how deep learning techniques can be effectively used for a medical diagnosis. Thank you.